Department of Collegiate and Technical Education. Today we will discuss about advances queries in SQL, means structured query language. Module 3, Database Management System, 5th semester. Subject code 18 CS 53. In this session, we will discuss about giant tables in SQL and outer joins, aggregate functions in SQL, grouping, the group by, and having process, other SQL constructs with and case, recursive queries in SQL, then multiple choice questions, answers, references. Giant tables in structured query language and outer joins. The concept of a giant table or giant relation was incorporated into SQL to permit users to specify a table resulting from a join operation in the from class of a query. For example, consider a query which retrieves the name and address of every employee who works on or who works for the research department. See this query, select first name, last name, and address from employee and department table. Here we using the word join. We select the first name, last name means employee name, and address from the employee table and department table who works for the research department, and on department number is equal to the number, department number, where department name is equal to research. This is the example of using the word join in SQL queries. Here, from class contains a single giant table. The attributes of such a table are all the attributes of the first table, employee, followed by all the attributes of the second table called department. The concept of a giant table also allows the user to specify different types of join, such as natural join and various types of outer join. In a natural join on two relations, for example, R and S are the two relations, no join condition is specified. No join condition is specified. It's called a natural join. There is no conditions. Generally, you are using the join keyword. An explicit equijoin condition for each pair of attributes with the same name from relations R and S is created. Equijoin means you can retrieve the same name from the relations R and S is created. If the names of the join attributes are not the same in the base relations, it is possible to rename the attributes so that they match and then apply natural join. In this case, the as construct can be used to rename a relation and all its attributes in the from class. Next, we will discuss about aggregate functions in SQL, structured query language. SQL has a number of built-in aggregate functions such as count, max, min, sum, and average. Aggregate functions are used to summarize information from multiple tuples into a single tuple summary. Grouping is used to create subgroups of tuples before summarization. The built-in aggregate functions are count, sum, max, min, and average. The functions sum, max, min, and average are applied to a set of or multi-set of numeric values and return respectively the sum, maximum, minimum value, and average or mean of those values. These functions can be used in the select class. Aggregate functions are used in the select class or in a having class. The functions max and min can also be used with attributes that have no numeric means non-numeric domains. If the domain values have a total order among one another. For example, find the sum of the salaries of all employees. Find the sum of the salaries of all employees, the maximum salary, the minimum salary, and the average salary. Here we need to perform 4 aggregate functions: sum, max, min, and average. We using aggregate functions in the select class. Select sum of the employees, sum of the salaries of all employees, sum of salary, comma, max of salary, comma, min of salary, average of salary. Means salary is a attribute of the employee table. From employee, we retrieving the salary attribute from the table employee and then perform the aggregate functions on this attribute. Then grouping the group by and having classes. In many cases, we want to apply the aggregate functions to subgroups of tuples in a relation where the subgroups are based on some attribute values. For example, we may want to find the average salary of employees in each department or the number of employees who work on each project. In these cases, we need to partition the relation into non-overlapping subsets or groups of tuples. Each group or partition will consist of the tuples that have the same value of some attributes called the grouping attributes. SQL has a group by class for this purpose. The group by class specifies the grouping attributes which should also appear in the select class. The group by class also appear in the select class, so that the value resulting from applying each aggregate function to a group of tuples appears along with the value of the grouping attributes. For example, for each department, retrieve the department number, the number of employees in the department, and their average salary. select department number, retrieve the department number, the number of employees in the department, count of star. Count of star means it retrieves all the employees from the employee table. Average of salary, it returns the average salary of all the employees from the employee table. Select department number, comma, count of star, comma, average of salary from employee. Group by department number. Here, grouping the employees by department number. Next, other SQL constructs with and case. The with clause allows a user to define a table that will only be used in a particular query. It is somewhat similar to creating a view that will be used only in one query and then drop. For example, with big departments, department number as select department number from employee, group by department number having count of star greater than 5. Select department number from count of star from employee where salary greater than 40,000 and department number in big departments, group by department number. Here, SQL also as a case construct which can be used when a value can be different based on certain conditions. This can be used in any part of the SQL query. The case clause is used in any part of the SQL query where a value is expected, including when querying, inserting or updating tuples. Next, recursive queries in SQL. This syntax was added in SQL 99 to allow users the capability to specify a recursive query in a declarative manner. The recursive queries are added in the SQL 99. An example of a recursive relationship between tuples of the same type is the relationship between an employee and a supervisor. With recursive, here using the what's with recursive sup underscore emp means of super SS social security number, comma emp employee social security number, supervisor social security number, employee social security number. Yes. Select supervisor social security number, social security number from employee. Union select e.ssn employee social security number, comma supervisor, comma dot supervisor social security number from employee as e, comma sup underscore emp yes, where e dot supervisor ssn is equal to s dot emp ssn. Select star from sup emp. Okay, we discussed about 6 classes. A query in SQL can consist of up to 6 classes, but only the first 2, select and from, are mandatory. The classes are specified in the following order, with the classes between square brackets being optional. A query is evaluated conceptually by first applying the dash class followed by dash class to select and join tuples, and then by dash and dash. A query is evaluated conceptually by first applying the from class followed by the where class to select and join tuples, and then by group by and having the answer. Thank you for watching this video.